So thank you very much. As Dan said, I'm Steve Smith. I go by Ardalis online because Steve Smith is a crazy common name that is hard to find a common sequence of S. Smith or Smith S. or Steve S. or whatever on various platforms. So I'm just Ardalis everywhere. And you can find me on Twitter there or GitHub. And if you want to email me, you can email me at steve@ardalis.com. So if you have any questions after today, feel free to just send me an email. If you have any questions as we're going, definitely don't wait till the end. Just feel free to throw them in the chat and I'll try and keep an eye on that. And if Dan or any of the other organizers, want to just pop in and let me know if there's a question that I missed or something, that's totally fine. It's as a virtual presenter, it's not nearly as engaging for any of us if I'm just talking to a blank screen and have no idea of anyone else like listening or getting anything out of it. So it is nice that most of you have your cameras on, so I can at least see that you're there for the most part. Because a lot of times that's, I just talk to my screen and there's no one even there. But yeah, feel free to ask questions as we go, and I'll stop and I'll go down rabbit holes with you and answer your specific questions if you like. Otherwise, I'll drive on through my content and hopefully there's some useful bits in there for you. All right, that's the wrong app. Let's go back there. Do that. All right. So if you are interested in learning more about these topics that I'm going to discuss in terms of principles and refactoring techniques and code quality, I have some courses on Pluralsight. If you have Pluralsight access, if you don't, you can get like a 10-day thing if you go to their homepage. If you've already done that and you still want to get access to something and you don't want to pay any money, shoot me an email. I can probably get you a 30-day trial code so you can check out some of these things without having to buy anything. I do have a totally free, as in beer, ebook that you can find at the link there that says ardalis.com architecture ebook, which is on architecting applications on ASP.NET Core. That goes along with Microsoft's reference application that I help maintain on GitHub called eShop on Web. So if you just Google for eShop on Web, you'll find the sample app. The book is linked to from there. It's also available just purely online or as a downloadable PDF. I do mentoring and training for individuals and teams. So if you're interested in leveling up your software team or your career, you can ping me for that. I have a group mentoring program I started a couple years ago called devbetter.com. That's all about helping developers with their careers. So if that's interesting to you, check it out. I have the podcast that was mentioned. I do stream on Fridays, like 12 to 2 Eastern time. Which right now it's 2, so this is about when I'd be ending typically on Fridays. So subtract 2 hours and whatever that time is for your time zone, that's about when I'd start if you're interested in hanging out on Twitch sometime on Friday, late afternoon or evening, I suppose it would be for you. Okay, so some of my Pluralsight courses, I talk a lot about design patterns of late because they've had me updating older courses, and I did a lot of courses a long time ago. I've been an author with them since 2010. And some of my other stuff is on refactoring and solid principles and domain-driven design is another big one. So those are the kinds of topics that I've been passionate about for the last decade or so, and I've spent a lot of time with both at conferences and with Pluralsight and other private corporate training. So the key thing I want to talk about today in the context of improving the design of existing software is to start off with the problem and then look at some different ways that we can address that problem and how we can improve our software in place without having to throw it away and rewrite it. And the key problem that leads to all of this is the fact that software tends to rot over time. It spoils. It gets worse if you don't give it ready maintenance and continuous small improvements. And it's just like the engine of your car or any machine. If you don't do that kind of maintenance on it from time to time, eventually instead of this well-oiled machine, you get something that looks like this. And it's not good for anything but the junk heap. And so there's a term for this that's been around for a while, and I'm sure most of you are probably familiar with it, and it's called technical debt. And this was coined like 20-some years ago, and it basically refers to low quality code and shortcuts in our application. And the reason why this debt metaphor makes sense and has kind of stuck is because debt has 2 components to it. You've got this principal, which is the raw amount of debt that you owe somebody or a bank or whatever, and then you have interest that you have to pay, and you pay the interest, periodically on some schedule, or else people come looking for you, right? And so in the context of your code, the principle is the sum total of the amount of effort it would take to get your code into what would be a quote unquote ideal state, ready for any change that might come your way. And the interest that you're paying day to day and it's accruing on your code is the amount of effort it takes for you to work around those design imperfections in your code that make it so that the bug that you're trying to fix, the feature you're trying to add are a little bit and sometimes a lot more expensive than they would have been given that ideal design. And there's a chart that I like, which is not at all new. This is from 2008, that kind of takes these different components and puts them all in one graph. So it's a little bit complicated. So let me walk you through it. The dashed line that's right here represents the optimal cost of changes to your system. And so it rises gently over time because a larger system tends to be a little bit more difficult to understand and change than a much smaller system like the 3 months after you started the thing. And so it's natural that that cost is going to increase. However, any kind of technical debt that's occurring as you work on that is going to increase that change from whatever that optimal line might be. And so this like thin black line here represents the actual cost of change. And the difference there is that technical debt. And I see a question, what do you recommend for being able to quantify the technical debt to management? There are some tools that try to do this. If you're doing .NET code, probably the best one out there that I'm aware of is NDepend. If you're not familiar with NDepend, it's a static code analysis tool. It'll find lots of opportunities for your code to be better. You can define your own rules if you want. You can pick and choose which of their rules you use. And they have things in there like, you have a constructor that has more than, let's say, 7 parameters on it. Probably that class is doing too much. You should refactor it. Right. And so that'll show up as a warning in this static analysis tool, and it'll have a technical debt number assigned to it that the makers of NDepend have put together. And it'll say that this will take 15 minutes for someone to fix or half an hour, or whatever they, said, which is obviously just sort of a guess, right? But a refactoring to take a constructor with too many parameters and turn that into something with fewer parameters takes, on average, they think X amount of time. And then it will give you a sum total of all that. And so your large legacy project, you pointed at NDepend, and NDepend says, you have 17 years of technical debt in this project or whatever, in terms of like raw developer hours to correct all the things. And where that raw number is probably not terribly accurate, but what it is useful for is you can track whether or not that number is growing or shrinking over time, and so you can communicate to management or your peers. Are we moving things in the right direction in terms of technical? Are we just making things worse and digging our hole deeper, or are things improving? And the biggest thing you need to do if you find yourself in this pit of technical debt is stop digging. And find a way to start filling it back in and getting yourself out of that hole before you get in deeper still. Okay, so then the last thing on this chart that I want to point out is there's an inverse relationship between the cost to implement a change and how quickly you're able to turn around changes for customers. So this red line up here is your customer responsiveness. And so as the actual cost of change grows asymptotically, which happens with many large systems if they aren't maintained very well, eventually it becomes more expensive to maintain the system than it is to just rewrite the system and give it another shot, right? Try and write a new system that solves the customer's needs, because the old one is too scary, too big, too buggy, too whatever to continue maintaining. All right, so another follow-on question about this: can you set it to run on build? Yes. NDepend will run on a developer machine, or you can run it on a build server. At the moment, you can't run it in GitHub Actions, but you can run it as a service, as a plugin in Azure DevOps. So if you've got TeamCity as your build server or Azure DevOps as your build server, you can run it there. The only place that's not yet supported that I know of is on GitHub Actions. Well, I'm sure there's other places it's not supported, but the only place that I commonly build things that it's not supported is GitHub Actions. All right. Yes. Okay. So the other thing you can think about with technical debt is the type of technical debt. And this doesn't really change the math in terms of what kind of debt you have, but it can change how you feel about it. And you might think about what kind of new technical debt you're accruing based on this. So we can organize it based on two questions, right? Is this technical debt something that we incurred recklessly or prudently? And did we do it deliberately or accidentally? And so the top left would be deliberately reckless of saying, we don't have time for design, we're just going to start coding and ship something. And so you know that maybe if you spend a few minutes designing the thing or iterating a little bit on your initial design, that you might come up with a better design. But you're not going to have time for that. You're not going to make time for that. And so you're just recklessly going to incur whatever technical debt that occurs. Prudent, deliberate technical debt would be, we know that this isn't necessarily the best way to do it, but we have a deadline to meet. We have a demo tomorrow. We just need to show something. Let's just hack something together and throw it over the wall. And even though it doesn't really work, that we get it. Like if the customer makes the sale, we'll go back and fix it. Accidental, like reckless, would be you just don't know better, and maybe you have inexperience on your team. Maybe there was some design pattern that would have made your life so easy, but you didn't know that at the time. And then prudent accidental would be, now we know how we should have done it. This isn't so much necessarily referring to technical competence as your understanding of the business, or the business's understanding of itself has improved to the point where now you understand better how you might model that if you had it to do over again. And sometimes the business model itself is shifting under you as you're trying to build a system to model it. And you end up with that type of prudent accidental debt where you started modeling for the system that originally you were being asked to build. And now the requirements are a whole different type of system, but you're still on top of that architecture that you started from. Question on, will the slides be shared as well? The whole recording, or the whole meeting, is being recorded, so you can refer to that. As far as the slides, I can certainly send a PDF to Dan, and he can distribute it to anyone that wants it, if that works. Okay, preventative maintenance is the way that you keep technical debt from growing out of control, just like the way you keep your car from grinding to a halt because it has no oil in the engine, assuming that you're still using one of those old school combustion engines that uses oil and stuff. And so refactoring is the way that you do that in your software. And so with refactoring, the main goals for refactoring are to eliminate duplication and simplify the design of the system so it's easier to understand and easier to change. The other thing that goes hand in hand with refactoring is automated testing. And this gives you three things. It gives you some better confidence that it is correct, and also helps you avoid regression. So when you change something over here in your code, it doesn't break something over here in your code, which is always a surprise when it happens, but it's not surprising to any of us with experience that it happens, because it happens with some frequency. The point about increasing confidence is important, because if you don't have any testing, if you don't have any automated tests, and you have a large legacy system where legacy, I'm going to use Michael Feather's definition of that, which means your system doesn't have automated testing covering it. You aren't going to be necessarily very confident that if you make some ambitious refactoring change, you're going to like totally redesign how a certain part of the system works, that it's still going to work when you're done. If you have a system that you've built and very carefully tested it with automated tests as you've built it, and then suddenly you're like, oh, the customer needs this, well, that's going to require me to totally redesign how I design this thing. You do it, you run all the tests, they all still pass. You're pretty confident you didn't break the whole world. It's still possible bugs will sneak in, of course, but your confidence to even take on that type of ambitious refactoring is greatly increased when you have that safety net of automated tests to catch you if you make any bugs, make any errors. So another common question that people ask is, when does it make sense to refactor? And so the question about this is usually in the context of, we don't have time to refactor because the refactoring, our customers don't see any value from that. And so, we have to just deliver because they expect things and they're always harassing us about deadlines, and we don't have time to do it right. So, we'll clean it up when we get a chance. And then eventually we beg the customers for the opportunity to let us have a refactoring sprint, or just a chance to clean up the code for a sprint in lieu of delivering features and bugs that they're asking for. And I often use this story of imagine that you had a restaurant that you went to, and you were a regular there. Like every Friday you went to this restaurant back before global pandemics and things prevented you from maybe doing that. And so you and your spouse or whomever would go, and you'd enjoy a nice evening and have your dinner and whatever. And then one Friday, as regular as clockwork, you go to the restaurant and there's a sign on the door, and the sign says, "We're sorry, we're closed. We'll be opening a month from now. The health department came in and, they didn't like our kitchen. So we need to spend the next month cleaning things up to get us back into a state where we can deliver the food that you've come to expect from us. Now, there's two responses that you should be taking from this as a patron of this restaurant. The first one is, oh man, I'm not going to get the feature that I wanted right now. I'm not going to get to enjoy that evening meal with my spouse. And the second one is, do I really want to keep coming back here if they had to shut down for a month just to clean up their space to the point where they could actually prepare food? Isn't that something they should just be doing like all the time? And your customers, have that same expectation, right? They don't expect that you're making a mess of everything as you go, and then at some point you're going to be like, no, wait, the mess is too big. We need to clean it all up. They're expecting that you're writing software where soft means malleable and changeable, and that over time, if requirements change, which of course they will, you're going to be able to change. And if you have these things like sprints or iterations that you're talking about, that kind of implies that you're using some type of agile methodology. And so a customer is rightly going to think, I thought we were agile. I thought that meant that we could change. I thought you embraced requirements changes as part of your whole methodology. What do you mean we can't change anything for a month while you go fix stuff? And so, that's part of what I dislike a little bit about Scrum as a methodology versus XP, extreme programming, is that Scrum does not make any reference to code quality. There's nothing in Scrum that says, okay, in addition to all this other ceremony and people with special names and stuff like that, we're also going to write really good code that we could change when we need to, right? It doesn't mention that at all, just kind of leaves the code quality out of it. Whereas extreme programming is very clear about the need for writing quality code that is changeable and that can be refactored and changed to meet demands. And so it's unfortunate, I think, that of the two, Scrum won the marketing war, mostly because nobody's trying to sell XP certifications. But that's an aside. So to answer this question, when should you refactory? As the three words on the slide have said for some time now, you should ideally do it while you're delivering value, right? Don't try and separate out the refactoring from the regular work of fixing bugs and delivering features. But when you're fixing a bug, when you're delivering a feature, and you identify a place where you might improve the design of your code by refactoring it, that's when you should do it. Do the refactoring to make it so that delivering that feature, fixing that bug is easier than before you refactored it. All right, so yep, okay, nothing else new there. Or you wrote your line of business app in Silverlight. Yes, that would be a big technical debt, but you could still move it to WPF, kinda-ish, partially, and as long as you didn't want it to run on the web, which, if you're writing Silverlight, probably you did. But yeah, that's fair. If you wrote it on a platform that doesn't exist anymore, that's not really technical debt. That's a whole different problem. Mike asks, in your experience, what do you think is the percentage of companies which do refactoring on a daily basis? Maybe 10%? I haven't worked in a company which does it, unfortunately. I would hope it's way more than 10%. Pretty much every company I work with does some kind of refactoring on a daily basis. Yeah, like every time you add a new feature, there's probably some design that you could fix and change and refactor. So if you're in an organization where that just never happens and you think that 90% of the industry is just like that, then I feel sad. You can try and change your organization, or you can change your organization, if that's the case, and if you feel like this is something that you would like to be in an organization that wants to make the code better as they go, and not have it just get worse and worse and worse over time until it falls over under its own weight. But no, I'm more optimistic about it. I think I've been in this industry for over 20 years. I'm getting gray, and it started for me 20 years ago. Testing was like do we really need that? Continuous integration was like, well, we don't have time for that. That's, you got to spend all this time setting up a build server and stuff. That's crazy. We can't afford another server just to do builds. What are you talking about? Now testing is pretty much, yeah, of course you should have some tests, and it's a question of, well, which tests and how many, not do we even do that. Continuous integration, everybody does continuous integration. If you're not doing continuous integration, you're definitely on the wrong side of history a little bit here. There's no debates about it anymore about whether or not it's a good thing. So refactoring is kind of in that same line. Like, companies have recognized at this point the value that quality code has in their long-term success. Most companies, right? If you're at one that doesn't, you can help them to see that light and hopefully help them survive that next competitor that comes along that forces them to shift directions. Or you can maybe think about finding another company if that's something you'd like to be a part of. Dan says, I've worked with companies where everything's on the clock and everything's rushed by management. This is where TDD really builds up, or TD technical debt really builds up. move companies if you work for a company like this. Programming is much more enjoyable. Yes, I would definitely agree that if you work in a system that has unit tests and has quality code, it's so much nicer because you can be free to just do what you want to do to try and solve problems, and then run some tests and verify they work, and iterate and try different things and see if they work. And it's not like, oh, I'm stressed, I got to figure out if this works, and I've got the boss breathing down my neck, and I keep trying things and none of them work, and then eventually something magically works, but I'm not sure why, and then I toss it to QA and hope they don't destroy me. Like, that's not as nearly as fun of a way to do it as where you've got confidence that the system works. Mike says, maybe you'll talk some other time about how we can really convince our managers to do it. Well, convince them that they need a consultant and they will pay me to come talk to them. And then even if I say the exact same thing you're saying, they will listen to me more because they're paying me for it, even though they're paying you too, right? Managers don't make any sense like this. So if you can get them to bring in a consultant, it doesn't have to be me, just somebody that they think knows what they're talking about, and then you have a conversation with that consultant ahead of time and say, here are our problems, here's what I think we should do to fix them, and the consultant's like, yeah, okay, that makes sense. Maybe they'll change it a little bit, but if by and large what you're saying makes sense, they'll be on board. Then they can go and say the exact same things you've been saying, and management will be like, okay, yeah, all right, this consultant says we should do this. Mike, the consultant says we should do this, so I think we should listen to them. And you're like, that's what I was saying, but you don't say that out loud. And you're like, yeah, I think that's a good idea. And that can work really well, right? It's a cliche that happens in organizations because it works. So, okay. The key thing to remember here is that you should not need to ask permission to practice basic hygiene when you write software. You may have conditioned your management, or your company may have this culture where they feel like it's optional to refactor the code or to clean up the code as you go, or to do the things that help make sure that the code doesn't have a ton of technical debt. And it shouldn't be, at least some degree of that shouldn't be optional, right? You at least should be confident your code does what you think it does. And the only way that I know to do that efficiently is through automated tests, right? I could manually test it, but that starts to fall over very quickly. And at some point, me manually testing all the scenarios that my code is doing is really just stealing from my client, or my employer, because it's, my time is very expensive. And for me to manually test all those things that a computer could have done in milliseconds is not a good use of anyone's money or resources. Also, when you go get surgery, the doctor doesn't come to you and say, I've been reading these journals and they suggest that I probably ought to wear a mask and wash my hands. But if I do, it's going to slow me down and I'm going to have to charge you a little bit more for the surgery. What do you think? Should I do that? How badly do you want this to be, high quality surgery versus me just getting it done quicker and you not having to pay quite as much? Like, they don't do that. They just do the things they're supposed to do because they're professionals and that's what's expected. We hope, right? And so as professionals, we should kind of take a note from that and do at least the basic levels of hygiene in our code that we need to keep it from getting worse and worse and worse over time. Liam says, remember, if you have to get a consultant in to change management's mind, don't get PO'd, accept management are stupid, but you are now going in the direction you want. Yeah. Okay, so make cleaning up your code just something you do as part of writing your code. Like, before you check it in, you go and you look through the code, you clean up things. If there's a bunch of commented out code, you get rid of that. If there's a bunch of code that has really stupid names, you fix those names. There's basic little things that you could do to make it so that you're happier with the code before you check it in, before you do a pull request. That's another thing that used to be like, didn't exist. Like, pull request, the whole term didn't exist like probably 10 years ago. I'm not sure how old GitHub is, but GitHub really popularized this concept of pull requests, where now it's a common thing that even if you're not using them, you probably at least have heard of them, I hope. And if you haven't, a pull request is where you submit some code to a repository, but instead of just checking it in directly, you submit a request for them to accept your code. And there's a conversation that takes place and you can review that code. These are a great tool for ensuring that code quality is taking place. If you're not sure about how you named something, or if you're not sure what algorithm would make sense here, or which service to call, or whether or not you needed a unit test, all those things could be discussed in a pull request if you're on a team that has a culture where those are used and taken seriously and reviewed. And I think they can dramatically increase the quality of the resulting software. It's time and place for things. Even if you're under pressure, you can still do Boy Scout coding, which is to make things better than it was, even if you can't change it all. Good segue, Adam. So there's a slide that I have right about now called the Boy Scout rule. And the Boy Scout rule, if you follow it, is basically that you want to leave your code better than you found it. And that is the like the Boy Scouts in America, which are now just the Scouts. They would use this rule when they're going camping, and the intent of it is that it is not their responsibility to clean up every mess and every little bit of anything that was on this campsite before they got there. Right? If it was already somewhat messy because previous campers had been slobs, that wasn't their fault, that wasn't their problem. But if they just leave it better than they found it, they're at least not making it worse. Right? So again, back to the doctors, it's kind of the do no harm philosophy, and they're improving it, if only incrementally. Right, so you don't have to completely overhaul your code and fix all the things you see wrong with its design on this commit. But if you make this commit, improve the design ever so slightly, right, make it just a little bit better than it was before, and you do that consistently, then over time, you're going to pay down that technical debt and you're going to keep it from getting worse. You're going to stop digging that hole deeper and deeper. When we talk about refactoring, we want to be clear what that is. So refactoring should not change system behavior. Right? If you're changing the system behavior, you're not refactoring. You're fixing a bug, adding a feature, probably adding a bug, one of those things. But you're not refactoring. Instead, the refactoring process is to verify what the system does. So you have to know what it does, ideally, first before you change it. Then write characterization tests if none exist. So if you're familiar with various tests, unit tests, integration tests, functional end-to-end, whatever, characterization tests are a specific kind of test. They don't test that something does what it's supposed to do. They just test that something does what it does. So you can write a characterization test even for legacy code, even for like this big console app that doesn't do anything but log a bunch of output. You could write a characterization test for that says, okay, given this input, it logs all this stuff, I capture that, and I put it in a text file. When I run it again with the same input, I should get the same output, right? Maybe minus a few dates changed or something like that. And then you can make changes to that system, and then you can run that characterization test to at least give you some confidence that it still gives you the same output. And they're easy to write because when you go to write a characterization test, you can write it as a standard unit test with whatever unit test framework you use. But instead of saying assert dot equal the thing I expect is this thing, you say assert dot equal something that isn't right, and then call the thing and it'll fail, and it'll say, oh, assert equal failed. You thought you were going to get 0, but actually you got this block of text. Okay, take that block of text, replace 0 with it, run the test again, and assuming you're not testing a random number generator, you should now get the test to pass. It should say yes, now it equals the thing that it was before. Great. Save that test. Now that's your test that you're going to run as your refactoring. This is for if you don't already have automated test coverage for a system, like for legacy systems. Then you can apply your refactoring, then you can confirm that your existing behavior was preserved because you have that test. And if the only thing you can do with a really awful legacy system is do a manual test, then do a manual test, right? Write a little script, say I'm going to go through these steps, and when I'm done, I should expect to see this. Take a screenshot if you want to. And then when you're done with your refactoring, go through your manual test script and verify that you got the results. Here's the process I just went through for the characterization test. So I'm not going to go through it again, but that's basically the steps. Okay, then spaghetti code is just a type of code that you want to avoid. It signifies that you have some technical debt. It goes hand in hand with the separation of concerns principle. And the idea with spaghetti code that you want to avoid is that it has intermixing in the same module, in the same lines of code, different concerns. Like you've got user interface concerns coupled with your business logic, inside with data access logic, with security and authorization checks and other things, all just intermixed. That kind of code becomes very difficult to change and maintain over time, because if any of those things change, you've got to parse through all of that logic to make those changes. And it's a bit like trying to untangle a big mess of chords or something. And so that's where this diagram came from. A few years ago, we had calendars that we made for software craftsmanship, and this was one of the images from our software craftsmanship calendars. All right, so real quick, let's talk about the solid principles and specifically how they apply or how we can use them in the context of refactoring and improving our code design. So I'm not going to spend a lot of time on the principles themselves, but I am going to just use them as a heuristic to identify places where our code might be deficient. If you're not familiar with solid, I have a couple courses on Pluralsight that talk about them. You can see the definitions of the principles right here. I throw don't repeat yourself in with the list because it's one of the more fundamental principles in addition to the 5 solid principles. So the don't repeat yourself principle is really a fundamental principle for software development. And the idea with don't repeat yourself is that you don't have the same logic for the same thing in multiple places. And it's such an important principle that I'm going to repeat it right now and say here again, don't repeat yourself. And we did actually put it in multiple different years worth of the calendar because we thought that was clever. Here's what you can do with don't repeat yourself. So when you have dry violations in your system, you can either duplicate or you can address duplication in logic through abstraction, typically through things like creating a new class or creating a new method, putting the duplicate logic into that class and or method, and then calling it from all the places that previously had that duplicate code. If you have duplication in your process, that means you're like constantly doing the same set of steps for a certain thing in response to a certain stimulus. You can deal with that through automation. For the purposes of this talk, we're mostly going to talk about the former. So common refactoring is when you see duplication in your source code and it's not coincidental, right? It is perfectly okay to have coincidental duplication in your code. You don't need to get rid of all repetition in your code. How do you know the difference? Well, coincidental repetition is where the same steps or lines of code or logic exists in 2 places, but the 2 things are totally unrelated from one another. And it's not that there's some fundamental rule that they're both following. And so what you have to realize when you apply any of these refactorings for dry, you're adding coupling. You're saying, okay, these 2 things that used to be totally unrelated and had this duplicate code, I'm going to have them both call this one method. Now these 2 things are coupled together. Right? They didn't used to be, but now they are. And that's a trade-off that you just have to recognize. It's not good or bad. It's just important to realize that that's a thing. And if they shouldn't be coupled together, then don't refactor out the duplication. Craig says dry is probably the most misunderstood. People interpret it as not duplicating code when it really is not duplicating knowledge. And yeah, that's a good way to think about it. Right? It has to not just be the same lines of code that look the same. It has to be the same concept in the abstractions of the model of the system. It would be silly, for instance, for you to go through your system and find every instance where the literal number 2 existed and refactor all of those away to some, get number function, right? And so anywhere the number 2 exists, now you call get number. And now at some point you want to change from 2 to 3 in one place. And it's like, oh, well, I guess get number needs to take in a Boolean that says whether or not it should return a 2 or a 3. And now suddenly get number starts getting more complicated with all this if conditions to make it work for all the places that call it. Whereas if you had just left the duplication in place, they could have all changed independently and been just fine. Right? So just be aware of that. Okay, so an example of a place where you can get rid of duplication, where it really is the same conceptual thing that you're duplicating, is role checks. And I see this especially in legacy ASP.NET web forms and even MVC code. A lot of that, at least it's pulled up into attributes, but sometimes in the actions, you'll still have code that looks like this where they're doing role checks. And you end up seeing this all over the place. And if you have a system that is still growing, especially, and it has this notion of roles that was added as like the only mechanism of authorization where either you're a regular user or you're an admin. And then later on, it gets more granular. It's like, well, you could be a regular user or an admin, or you could be a member, or you could be a manager, or you could be this, right? And now every single place where you've got this user in role check, you have to go back and touch it and say, or you're a manager, or you're an account manager. And it's difficult to maintain that, and it's easy to miss places where that might have been the case. What you can do instead is use an abstraction like a privilege. And what a privilege is it describes the types of actions you could take on a particular resource. And so you have a privilege as just an abstraction. It's just a class. You pass into it the things it needs to make a decision about who could access this class. So in this case, if I have a content privilege that's describing actions I could take on some content on a CMS type of system or blog system, and I could say for this user, for this article, can they edit it? Right. And the rules for that might be like, are you an admin? Yes, then you can edit it. Are you an editor? Yes, you can edit it. Are you an author? Well, now you can edit it, but only if it's your article. If it's not your article, then you can't edit it because it's someone else's. Right. So all of that logic, instead of having it be scattered about in your controllers and other places, you would put inside of this privilege type. And then you could just new up a privilege anywhere you need one and call methods on it like can edit, can, save, can publish, whatever, and use those checks at a higher level of abstraction. And now your role checks only have to live inside privileges. They don't have to live everywhere throughout your UI. Let's see. Arthur says, maybe you'll talk some other really convinced. At one job, we had a scrum master who was measuring waste. Every retro, we discussed blockers, waste, time spent, CI. He measured our estimates, how much time we wasted waiting, fixing random regressions, rush things, but not testing enough. Numbers like 20,000 or 20,000 for 4 months for 2 teams spoke much clearer picture to the COs than spoken, we need to fix technical debt. That's a good point. Yeah, if you can put some type of metric around what is it actually costing for dealing with this technical debt in terms of actual hours spent, and then you convert that into your salary and say, here's how much it's costing. We can if we spend the time changing this, we can bring that down. That generally helps from a cost perspective. Honestly, most businesses, if they're going to be if they're not like a stable utility or something like that, or something that just has fixed margins, most businesses would be wise to think more about upside than cost side. So if you can say, hey, if we're able to change faster, like if you're like a startup or somebody that's trying to compete against startups, and you need to be able to quickly deliver stuff to market so you can out pivot or out compete some other smaller and more nimble company. Time to market probably matters more than cost in terms of time spent and waste and things like that. And so there's 2 ways to look at it, right? It's how much time do we spend trying to work around technical debt, and what does that work out to in terms of our salary cost, but also what is our time to market? Like in this quarter, we managed to ship 4 major features. Had we not had all this technical debt, it would have been 6, and our release would have shipped a month sooner, and we would have made it in time for the trade show, and it would have closed that $1 million deal, and it would have saved, we would have made $1 million more this year. Like, that means a lot more than, and we would have saved, $5,000 in salary. Like, that's the part where the numbers get big at that point. The savings is still there too, right? But the upside is much bigger on the revenue side, typically, if you can show that. And you don't have to show it with necessarily real numbers. You can paint a picture like I just did, even in the abstract, right? And just kind of give them like some rough back of the envelope numbers and say, I could get you much better numbers, but it would take me a lot of time and money, and that's what we're trying to save right here, right? But it shouldn't be hard for you to figure out that there is some benefit here, and it'll be realized as additional sales if you're in a business where that matters, right? Some businesses, they're not, so it's not that important to them. All right. Another place where you end up with problems is where you do argument validation, and you have a lot of duplication like this, where you say, if the order is not null, then if the customer is not null, then right here in the middle, we're going to process the order. Otherwise, throw this, otherwise throw that. And you do this on lots and lots of methods, and all the methods start to kind of look like this, and they're very repetitive, and they're very ugly, and they're not very intention revealing. Like, here's all this plumbing and ceremony, and here's the actual thing that's important that we're going to do here. And so something that fixes these really nicely is guard clauses. And so guard clauses basically look like this. They say, check for something bad and throw immediately, check for the other bad thing, throw immediately. Now, everything from that point down, is good, right? Your happy path is just whatever's left, because you've gotten rid of all the bad paths. And so that can help. You can further get rid of duplication by using a library for those, whether you have your own or use a third-party one. This is my NuGet package, Ardalis.guard clauses. I just found out last week it surpassed 1 million downloads, which is impressive. That's more than any of my other NuGet packages ever have. So it's just a really simple thing that lets you write code like this and check parameters. Not quite as important for null checks if you're going to start using the C# feature of nullable reference types, but you can write your own guard clauses for anything, right? So if you've got certain checks for like strings, or if this customer is valid because it meets these certain simple criteria, they're good for any of those types of things that you find yourself frequently checking. All right. Single responsibility principle basically says don't do too many things in one class. It says every object should have a single responsibility, and it should be encapsulated in that class. Robert Martin says should never be more than one reason for a class to change. Some folks don't necessarily understand the idea of what a responsibility is. So you might have developers that are like, well, I have a customer manager class that only does all the things for customer. That follows single responsibility, right? And it depends, like, what are all the things? Well, validates them and persists them and formats them and does reports and does notifications and sends them emails. And like, yeah, that's probably more than one responsibility, even though it is all just for customer. So responsibilities are things like persistence and validation, notifications, error handling, logging. Class selection, what does that mean? That means deciding specifically which classes this class is going to work with, right? That is a responsibility, and deciding which ones to new up. How you're going to format things, parse things, map things, et cetera, et cetera. So I call out the class selection one because a lot of legacy code tends to just overuse the new keyword. And it would just new up whatever things it needs. And so later on, if you want to change how that works, you want to swap out one collaborator with another, it makes it very difficult to do that because you're hard coding that dependency right in there. And so this excessive coupling, these dependencies, are one of the things that makes software more difficult to change, as well as more difficult to test. And so if we can take systems that are very tightly coupled, we can refactor them to be more loosely coupled. At the end of the day, we still need it to do all those things it does, but we can change those dependency relationships so that they're not as fixed and difficult to break later on. So common refactorings with single responsibility are to extract out a class, extract out a method, or move a method to basically take a big class that's doing too much and turn it into a couple of smaller classes that each do fewer things. There's some heuristics you can use to identify where you might have too much going on. One of the ones that I like quite a bit is cyclomatic complexity. And so you can use Visual Studio, depending on what version you have, to measure cyclomatic complexity. You can use other tools as well. I already mentioned NDepend, it can do that too. There's a lot of other tools. If you Google for it, you'll find tools that'll work with your set of whatever tools you use. But cyclomatic complexity is this column right here. And it measures all the different possible ways to go through a block of code if you branch at every branch point, every if condition or branching loop. And so this one right here, this update quality method, has 19 different paths through it. And this is for a software exercise or kata called the Gilded Rose kata. And this is an interesting kata because it helps you practice refactoring. Most software exercises start you with nothing, and they say, go implement this problem, right? Go solve this problem, write this code. This one, you start out with code, right? The code is there, it works, and your task is just to add a method to it, just add a feature to it. And it's really not that trivial to do because the code is so complex. And so generally what you want to do when you follow this exercise is refactor the code to make it easier to add the feature. And it kind of gets you in the habit of, well, how would I do this with my real code at work? How would I refactor code as part of adding new functionality to a system? And so if you've never heard of the Gilded Rose kata, just Google for it. There's a GitHub starter that has the starting code in like 50 different programming languages. And so you'll find one in C# or JavaScript or Python or whatever it is you'd like to use, and go from there to try it. A couple other quick points on cyclomatic complexity. A lot of tools will roll it up. So like Visual Studio will roll this up all the way to the program level here. It really doesn't make any sense outside of individual methods. So you want to worry about cyclomatic complexity at the method level, but then just ignore it higher than that. If you brought me in to evaluate your code and you said, look, see, here's our solution. And I pulled this up and I said, oh, your solution has a cyclomatic complexity of 10,000. Is that good? Is that bad? I don't know. It doesn't mean anything at all. But if I go look at your methods and I see, okay, all your methods are a cyclomatic complexity of 5, except this one that's 300. I'm going to be like, yeah, that one's got problems, right? I will know that one has issues. And so if you look at this on Wikipedia, there's been a fair bit of research on this. It's not a new heuristic, and 10 has a fair bit of actual evidence as being like a breaking point for where things start to get worse in terms of the ability to understand the code, ability to change it without bugs. So the general guidance is that you want to keep cyclomatic complexity under 10 for each method. You can export out that data into Excel, and then you can sort it. If you break it down in Excel to just say member, that'll just be all the methods. And then you can sort by cyclomatic complexity, so you get an actual view. So this is some real client code I looked at a couple years ago. And they did have some methods that were almost 400 in cyclomatic complexity and over 1,300 lines of code. And Visual Studio also has this maintainability index that's like an algorithm that uses these other 4 to give it a number from 0 to 100. And even it figured out that these things were a 0 of maintainability. I don't really like the maintainability index, mostly because their color code is horrible. So you come over here and you look and you say maintainability index of 44 out of 100. If that was your exam grade at school, your parents probably wouldn't be very happy, but it's still green. That's fine. It's green, right? There is a yellow and a red, but the bar for yellow and red is really, really, really low, right? Whereas it ought to be like 80 or 90 for yellow and red. All right, so you can use cyclomatic complexity to identify the biggest problem spots in your application, and then go and try and refactor those to break them up and make them easier to work with, especially if you're having to work with them anyway, right? Again, follow the Boy Scout rule. If you're not having to touch that code and it works, just leave it alone. But if you've got some bug that you're trying to fix or some feature you're trying to add, and working around this big ugly code is getting in your way, then think about breaking it up. Another heuristic that I use is aggregate complexity. So this is one that I created, and it's a pretty simple rule. You can implement it yourself, or if you go to this blog post, it talks about how you can use an end-depend rule for it. But basically, it calculates the cyclomatic complexity for every method in the project, and then divides it by 10 and drops fractions. So what does that mean? Anything that's from 1 to 9, and 1 is the minimum, but from 1 to 9 is going to work out to 0, right? From 10 to 19 is going to be 1. And so you get a number that it's going to probably be positive, but over time you want to drive that number down. As you take big ginormous methods and you break them up into smaller ones, your aggregate complexity for the project or for the assembly is going to get smaller and smaller over time. So you can track that in your build server, or periodically, once a quarter or something, look and see what is your aggregate complexity for the system, and that number should be trending lower. Or at least staying flat. If it's going up rapidly, that's telling you you're adding a lot of technical debt. You're adding a lot of really big methods that are doing too much. All right, another code smell, in my opinion, are regions. Regions are something I'm not a big fan of. I was going to wear my T-shirt that said "End Regions" on it, but I got busy with client calls and didn't have time to go change. But if you look at code that has this type of code in it, where you have a method, and inside the method you have multiple regions to try and tell you what they're doing, then probably I'm gonna say your method is doing too much, and instead you should refactor this out and use some other functions that you would call. And hey, I've got some ideas about what you could call those functions. You could call them validate input and set properties on post and stuff like that. Like, your region names are your method names that you wanted to call those things, so just call them. Yeah, Adam's got the right link for the Emily Bosch Gilded Rose Kata. That's perfect. What is deemed acceptable? 15 or 20? I think I answered that. It should be 10 or less, ideally. Sometimes you might be higher, but 10 or less is best. There are some classes that give you a deceptively high cyclomatic complexity you can kind of ignore. Like if you use AutoMapper and you have a mapping config file that configures all your mappings, it will typically have like a cyclomatic complexity of like 2 for every mapping that's on there. And so it's not unusual to have an AutoMapper config that's got like a cyclomatic complexity of 50 for a whole project. Yeah, but you could look at it and you can easily tell what it's doing, right? So those things I just tend to ignore from my heuristics, but they're still worth looking at the first time and then saying, okay, yeah, that's AutoMapper, that's fine, skip it. But real business logic, if it had a 50 cyclomatic complexity, you would have no idea what it was doing. Personally, anywhere. By regions, you only mean in methods or anywhere in a class? I mean anywhere, because if I have a method that I have to scroll, it's too long. And most of the classes I write only have 1 or 2 methods. So if I have to scroll in a class, it should be just a trivial amount. The thing I really hate is where you have a coding convention or standard that you're forced to use, and every class looks like this. Right, and so I open up the class and it's like this table of contents style region where I don't know what this thing does, and I don't know if it even has any static methods. Probably it doesn't. Most classes don't, but we have a convention or standard that every class looks like this, and there are organizations that use this, like real companies that you've heard of, and it's just painful for someone like me to work with this, because every single class I open up, I have to like go and try and dig around to figure out what the heck it's doing. And it just adds to the cognitive load, because when you're working, you want to work quickly. You want to be like, okay, I see this class does this. It calls this other class. What does this class do? And it's like, I don't know. It's hiding behind this cloak, and I have to pull it back to try and see what it's doing. The way you can think about regions, the way I think about regions, is regions are rugs under which you sweep dirt. right? Instead of picking up the dirt and cleaning your house, you just sweep the mess under the rug, put the rug over it, and now no one sees it, and you think you're okay. And eventually the rug has this big mound on it in the middle of the room, and it's hard to walk on, and like kind of crunches around, and dust lifts up as you step over it. But it's okay because there's still a rug covering it, and you kind of work around it and ignore that it's there. I saw that, Adam. That was good. So that's the reason I think of regions like that. They had a good place in C#1 and ASP.NET 1, which was you have generated code that you, the developer, should never touch, but we have to put it here. And so we're going to put it in a region so that you don't mess with it. So the original version of web forms had that, right? It had a bunch of stuff that had to happen in the web form to wire up all the events on the form. But developers shouldn't have ever had to mess with that or touch it, so they put it in a region. That's a perfectly good use case for regions at that time because we didn't have other solutions like partials. Now we have partial classes. We would never do that, right? We would put the generated code into its own partial. We'd put our code into a separate partial. Problem is solved. No need for hiding things from the developer inside their code. Yeah, so there's very few uses where I like regions. I will use regions when I'm refactoring a large legacy code base just to help me understand them and as an iterative tool to work toward refactoring things. And then I'll replace them with methods and other refactorings. All right. And I talk about regions here. So if you need some article on the internet to point somebody at, then you can use that one if you like. The next one is the open-close principle. By any chance, are local methods of code smell too? I don't really use local methods very much. I haven't found a good use for them. I've seen a couple potential good uses from folks I respect. So I do think that there exist good reasons to use local functions, but I have not made a habit of using them yet. So I've literally never used a local function in production code thus far. I've just played with them to see how they work. Okay, open-close principle basically talks about not needing to do surgery to add some behavior to something. And so it says that software should be open for extension but closed for modification. And what that means is that you can add new behavior, but not actually have to compile the code, not have to change the actual source code in the thing. And it's not new. It's from the 80s from Dr. Bertrand Meyer. And so some common refactorings you can use for this are to extract out an interface and then use the strategy pattern. You can parameterize the method, which I'll show you an example of in a second, or you can use a template method, which is another design pattern that works well for this if you have like a set of instructions that happen in a certain sequence. Have you read Your Code as a Crime Scene? Any opinion on book and described methods? I have not. I've heard of it, but I have not read that book. Have you used CodeMat for code analysis? I don't know CodeMat, so no to both of those. Sorry. I've heard of Code as a Crime Scene. That's on my list of books to pick up, but I haven't read it yet. CodeMat I've never heard of. So if you've got a book as a wide documentation of CodeMat, okay, I will look for that. I'm not even familiar with the MAAT term. I'm assuming that's an acronym and not some weird way to spell meat or someone's name. But yeah, I'll Google for that. Okay, so here's an example of an open-close principle failure, where let's say that I had a blog 20 years ago before everybody had a phone with a camera on it, and I had a digital camera and I could connect it with USB and I could write this code to suck down the pictures. And I would put them in the C:\Steve's photos folder. And then I thought this might be useful for other people. So I compiled it and I put the exe out of my blog and I said, here, you can download this. And people would download it and they would run it and it would work for them. And I would get feedback from them and they would say, why is this putting it in Steve's photos? My name is not Steve. And I would say, it's no problem. You can just edit the code and recompile it and then it'll work just fine for you. And of course, them not being developers wouldn't necessarily want to have to do that. They would like it if the code didn't do that. And so the really easy way to make this code follow the open-close principle would be to pass it in the destination folder as an argument. And so we do this all the time, right? We know that we can change the behavior of a method by just passing in another parameter and have that dictate what the behavior inside is. We can do that with classes as well. That's what the strategy design pattern is all about. If you don't know the strategy design pattern by name, but you use dependency injection, congratulations, you know the strategy design pattern, because dependency injection is the strategy design pattern. It's where you create an interface or some abstraction for a thing that describes how the class is going to behave, and you pass in different instances or implementations of that abstraction, and it changes the class's behavior, but you didn't have to change the class itself. And so this lets you very easily overcome problems with the open-close principle. Another example that's more likely to resonate with some of you that's more business logic related. Imagine that you have this method here that checks to see if someone is a quote unquote special customer. And imagine that this started out with one line of code. And then, another sprint later, the marketing team came up with another promotion, and now it was 2 lines of code. And fast forward, 6 months, and now it looks like this. And you can kind of see the writing on the wall that, okay, they're going to keep coming up with more promotions and more ways to give people discounts and try and sell more stuff. And so I think that this is going to get bigger and bigger. And if you calculate the cyclomatic complexity for this, you can see the cyclomatic complexity is growing over time because there's more and more conditional logic in here. And so a simple pattern you can use with this is what I call a rule engine pattern. And so you can just create a list of rules and then evaluate that collection of rules inside of the isSpecialCustomer. And what that means is that now all you have to do when there's a new special promotion they want to make is you just create another rule and you add it to the collection, or you load all the rules through reflection. And it makes it really easy for you now to extend this behavior without you having to touch this class again. Right? I never have to touch isSpecialCustomer again. It's done. The design now has moved to something that allows me to add more behavior by adding new files, by adding new classes. And it's always better, in my experience, to maintain a system by adding new classes than by changing existing classes. And there's a few reasons for that. When you add new classes, you're free to use whatever patterns, whatever skill, whatever knowledge you understand about writing software in that new class. Right? You're not beholden to all the other assumptions and design decisions that were made in the rest of the system because it's a brand new class. The other thing that's nice about it is because it's a brand new class, nothing else knows about it. Nothing else is depending on it. You can do anything in it, and you're not going to break anything else. So that's much, much nicer than going into a class that has a method with 1,000 lines long that's being called by who knows where, and then trying to make changes to it and expect that they're going to work, and that they're not going to break anything for someone. That's a lot more stressful. So whenever possible, refactor your code in such a way that additional changes can be made by just adding new types, by just adding new classes, and you can change the behavior in that way. I have a course that just came out. It's my most recent course, so a couple months ago, on the design pattern of using this rules engine. So you can check that out if you want to learn more about how to actually implement that, and it shows some examples. And then the next principle we'll talk about, I'm trying to go quick because I have a lot of content and I don't want to keep you all too late. Is the Liskov substitution principle. And it basically says that classes should be substitutable for their base types, not just follow the ISA relationship that you may have learned in basic object-oriented programming. So in this picture, you've got this toy duck, but it's probably not substitutable for a real duck in all places. So be careful with your abstractions and how you split things. So this was coined by Professor Barbara Liskov, who's an instructor still today at MIT. Also from 1988. So again, not brand new. It's been around for a while as a known principle. Common refactorings for this are just to adjust your inheritance hierarchy. So you can collapse your hierarchy. You could say, I don't really want to have a base type and a child type. I'm going to make that one thing. Or you can take individual methods or fields and push them up or down as needed in order to get to the point where things are substitutable for one another. A really common example you'll see about this if you start learning about it involves shapes. So you can say, like, I've got a rectangle, and rectangle's got a length and a width, and I can calculate the area or height and width or whatever, and I can say the area is height times width, and I have a square. And everybody that's ever taken geometry knows a square is a rectangle. So obviously I could use inheritance for that. And I could take a square. Well, a square is different from a rectangle in that the height and width must always match. So if you set my height, I'll just set the width too. And if you set my width, I'll just set the height too. And the problem you get with that is that now if you pass in a square into a calculate area method, and originally it was a rectangle, but now you've cast it to a square because it's substitutable, or you can now change its height, not change its width, and get out behavior that you weren't expecting. Another example that's more useful in your business software is something like this, where you've got a for each loop, and inside of a for each loop or some other polymorphic system, or a method call that takes in an employee would be another example of something that should work polymorphically. You are having to check the actual type of the thing. You have to say, if employee is manager, then do this other thing. Otherwise, just treat it like a normal employee. This is breaking Liskov substitution because you should not care if it's a manager. If manager inherits from employee, it should be substitutable for employee everywhere. And anytime you're going to work with employees in a polymorphic manner, it shouldn't matter whether it's a subtype or not. And the reason why this is a problem is it tends to get duplicated all over the place. Where if you start down this path, it's like the dark side. If you start down this path, forever will it, determine your destiny. Now you're going to have to go in all the different places where you ever are doing this and change them. Anytime you change this subtype relationship, you add another one that also needs to act special. Now you got to go change every for each loop and add another check. Well, if they're a manager or if they're an executive, do these check too, and it becomes a problem. You totally lose the benefit of polymorphism. What would be better would be either one of these, where you can say loop through the employees and just call their print method, or call some helper that can print any employee, right? Those would both be fine. You don't have a check now for what subtype they might be. So this is like a code smell to look for, where you see that type check inside a for each, inside your domain model and your code hierarchy. Another one that most people don't think about is null checks. So nulls actually break Liskov substitution. They break polymorphism. If you look at this code, it is exactly the same pattern, the exact same code as the check to see if that was a manager, right? You see here, if the employee is a manager, I'm going to treat them special and do something different. Otherwise, I'm going to print them. And we see here, if the employee is null, I'm going to do something special and print something other. Otherwise, I'm going to print them. And so the pattern is identical. So if you can avoid the possibility of passing null, and you can do that with nullable reference types. You can do that with guard clauses. You can do that with the null object pattern, which I guess I don't have a slide for, but there's another design pattern called the null object pattern that works well for this. Any of those patterns will work well to avoid the problem of nulls breaking your polymorphic code. All right. Next is the interface segregation principle, which talks about tailoring your interfaces to suit your client and not trying to be all things to all clients. The principle itself says that your clients should not be forced to depend on methods they don't use, which basically means you should have small, cohesive interfaces, not big, fat interfaces that do too many things. The most common refactoring for this is to extract an interface. If you follow this principle, you're going to end up with small, focused interfaces and hopefully not things that look like this. So this is the membership provider that ASP.NET 2.0 shipped with. And it was great because now we had membership built into ASP.NET. The problem was if you wanted to implement your own custom membership provider, you only had 1,700 different methods that you had to override in order to fully implement this thing, even if all you really wanted was register, log in, and log out. And so you would end up with most folks that would build these would not fully implement it. And so you'd end up with a whole bunch of throw not implemented exceptions all through here. Anywhere in your code that you see throw not implemented exception, you're automatically violating Liskov substitution principle because there's no way that that is going to be substitutable for its parent. And so interface segregation and Liskov substitution kind of go hand in hand because by having much smaller, more focused interfaces, it's more likely that your implementation is going to fully implement them and not be something that only implements part of it because it only needs part of it. Another possibility where you might see a failure in ISP is with repositories. I like the repository pattern as an abstraction. And I often use something that looks similar to this in my code. But one way that you might want to break this up would be if you have clients of your data access layer that only need to do writes or only need to do reads, then you're breaking the interface segregation principle by packaging those up together and having your reads and writes together. So and of course you probably have some classes that need both, right? I need to make some queries, then I need to make some changes, and I need to store those things, right? So some things need all of this functionality and some things need less, some things need a subset of it. You could take it to an extreme and have every interface be one method, but no one's really advocating for that, right? Except maybe functional programmers or something. But it does make sense to group them into like smaller sets. So this would be an example of how we could refactor a larger interface, whether it's repositories or anything else in your system, into smaller interfaces that do smaller things that are still cohesive among themselves. Now, the really cool thing about this is that if this were an existing system, let's say I already have a system, it's in production, it's been running, it's got this interface, it's used all over the place, and I'm adding a new class, and my new class only needs to do reads, right? And I don't want to depend on this repository anymore. I can create my own iRead repository like the one shown here, refactor iRepository to inherit from it, and nothing breaks. Everything else in the system that depended on iRepository still works. Right, it's got binary compatibility with the other way. So you can do this as a safe refactoring. You can break up your big fat interfaces into sets of smaller interfaces where the original one now just inherits from the other ones, and you don't break anything. And you get to be able to follow interface segregation principle much easier now as a result. All right. The other reason why you might want to do this is that there's different decorators, different types of patterns you might want to use with your data access. So for instance, on your reads, you might want to do caching. It doesn't really make a lot of sense to cache a write, so you typically won't cache those. But reads, by all means, that's where you get big benefits from caching. So you could put a caching decorator around your iRead repository, and then wire that up in your DI container, and everything will work great. Now your writes have another way to improve their performance and scalability, and that is to use messages or commands. All right, instead of actually creating the row right now and waiting for that database to do that insert statement right now, you could just create a command that says, hey, go create that thing, put it on a queue, right? And not actually do the thing right now. And so you could decorate your write repository with that, and then swap that in place of, or put it in front of your actual database repository. So those are some ways that you can use other design patterns in concert with these principles and these smaller interfaces. Let's see, I've missed a few questions. GitHub, okay, those are just those. All right, no, I didn't miss anything. Cool. Adam likes the strategy pattern. Good, me too. All right, so dependency inversion principle basically talks about wiring things up to low-level implementations, kind of hardwiring them. So the example here is like, would you use a plug and plug it into a wall socket that looks like this, or UK equivalent, or would you just wire up whatever it is you wanted to be attached right there, and punch a hole in the wall, find the electrical wire, and solder it together as needed. When you're newing code up from one class to another, you're basically doing that. You're hardwiring directly into it, and not providing a way for it to be plug and play in modular. So what the dependency inversion principle says is that high-level modules are basically like business logic and things that don't know about low-level details and I/O. High-level modules should not depend on low-level modules. Both should depend on abstractions. When we're talking about C#, when we say abstractions, we're mostly talking about interfaces. You could also use abstract base classes, but interfaces are the main thing. Abstractions, i.e. interfaces, should not depend on details. Details should depend on abstractions. So what is a detail? A detail would be how you're doing something, right? The abstraction is what do you need? So, at the business domain level, what do I need? I need to send a message to a customer, right? That's very abstract. I need to retrieve a list of customers. That's very abstract. Do I know where they're coming from? No, they might be coming from a file. They might be coming from a web service. They might be coming from a database. I don't care. I just need a list of customers from something. So your abstraction is your interface that says, hey, here, get me this list of customers, or hey, let me send a notification to a customer somehow. Your implementation knows the details. And so the details should not leak into the abstraction because they make the abstraction much harder to be reusable, much harder to be implemented on different infrastructure. So if my abstraction for getting a list of customers, instead of returning literally list of customer, it returns a SQL data reader, and I can read that SQL data reader to get customer details, right? It's going to be really hard for me to take that same interface that returns a SQL data reader and now point that at an XML file. Right, I'm going to have to go through a lot of effort to get that XML file to return a SQL data reader. Whereas if it just returned an IEnumerable or a list, I could point that at anything and it would work fine. All right, so dependency inversion principle says depend on abstractions, not concretions. Inject those dependencies into classes. Structure a solution so your dependencies flow toward the core. That's what the inversion of dependencies really means. And so there's a bunch of different architectural names for this. There's clean architecture, onion, ports and adapters, hexagonal. They're all basically the same concept. Here's an example of an onion architecture, which has these layers like an onion with consecutive spheres. In the center, you have your domain logic and your interfaces and your abstractions, and all around the outside in that purple layer, you have all the other things, right? You have your user interface, you have your infrastructure for how you actually implement those interfaces. You have various tests and other things like that. Dependencies that you would want to invert and that you would want to keep away from being tightly coupled to your domain or your business logic would be things like this. Not all of these can you get away from, right? Like framework. Framework, maybe you can get away from that a little bit. Let's say you decide you want to depend on net standard instead of on full framework or net NetCore 2.1, right? You could use NetStandard 2.0, and now you've got a library that can be used by multiple frameworks. But mostly, you're going to take a dependency on a framework and just live with it. Like, that's just how we tend to write software. All the rest of these, though, you can generally abstract away if you try. Third-party libraries that you might use, database, file system, email, web services, system resources like the clock, in addition to the file system, you can abstract away. Why would you care about the clock? Well, if all you're doing with the clock is taking a value from it and storing it somewhere, then you don't need to abstract it away. It's just a value. You don't care. But if you have logic that depends on that value and you want to be able to test that logic, now you might want to abstract that away in such a way that you could set it to whatever you want. And that's something that I see a lot in legacy systems that hasn't been done. And so somewhere in the midst of this big 1,000-line long method, there's a check that says, well, if datetime.now is in this range, then do this, otherwise do that. It's like, all right, I'm going to write a unit test for that, and it's going to work from 9 to 5, and it's going to fail the rest of the time. Like, that's not great. So yeah, if you can abstract out that can be better. Configuration is another one that you want to try and inject. And so that's where legacy.net stuff typically uses configuration manager.app settings to pull settings out of config. And it's just a static call, right? You don't inject it. You don't have an abstraction for it. You just grab configuration settings anywhere you need them. You can use config settings in NUnit or in some unit test, but only one, right? You only get one app config, right? So unless you want to create a different test project for every different combination of configuration settings you want to test, you're kind of stuck. And so you really want to make your configuration stuff an abstraction that you can inject in so you can test it with all different kinds of configuration. The new keyword, static methods, those are notoriously bad for coupling reasons. And then thread.sleep and random are a couple more that you sometimes optimize for in your tests. Sometimes your real production code really needs a thread.sleep, because it's waiting on some other process that's out of your control or whatever. And then so if you have a unit test that calls that method, and you're mocking out the other dependency, right? So it's not really going to call this long-running process. There's no reason for you to thread.sleep on that thing. You're thread.sleeping to wait for something that's not really happening. So if you mock out thread.sleep, you can speed up all your tests by saying, okay, thread.sleep actually doesn't sleep at all in my tests. Now my tests just all got a lot faster. And then random is really hard to test. But if you implement it as an abstraction, then you can test its various values. You can say, well, if that random number happened to be 4, what's the system do? And if it happened to be 17, what's the system do, right? And you can do tests now if you can inject in whatever value of random you want. You can also think about a lot of these other responsibilities we talked about with SRP in terms of dependencies. So, splitting these things out into different classes that have these responsibilities then makes it easier for you to see that they might also have their own dependencies as well that become implementation details that you want to kind of invert those dependencies with. Yeah. So questions, some folks, Adam likes the system clock, yes, as a thing to abstract. And yeah, you can abstract that out pretty easily. The other thing you can do if you don't want to abstract out the whole clock is just parameterize the date time that you need. So instead of saying datetime.now, wherever it is you want the current time, you can pass in current time as a parameter on whatever thing, and now it follows the open close principle a lot better. You don't have to worry about changing, the date time logic inside of it. You can just pass in whatever time you want, and then write a test that verifies that given this time, I get this result. Works really well a lot of the time. Dependency inversion principle refactorings are things like extracting out a class, extracting out an interface, using the strategy pattern, injecting back in the behavior using a strategy. You can extract out methods kind of similar to a single responsibility principle. And you can introduce a service locator or container sort of as a last resort, right? Ideally, you want to be using dependency injection, follow the explicit dependencies principle, which I think I have a slide for here, but if I don't, explicit dependencies just means your classes are honest about their dependencies in their constructor. So if a class needs to access a certain file, instead of it just doing that using system.io.file somewhere in the guts of the class, and not presenting that as a requirement that it has in its constructor, so that when you go to call it, if you don't have that file, it just blows up at runtime. It would be better if it said, I need an iFile provider in my constructor so that I can use that iFile provider to get this class. Right now, as someone that's going to use that class, I can try and new it up, or I can look at its constructor and say, do I have an iFile provider, right? Or at least that tells me this thing needs to talk to a file. It's more honest about what it needs than if it says, I've got a constructor, I don't need anything. I knew that up, I run it, and then I just wait for all the runtime exceptions to tell me what it actually needs. Okay. Another question. Alternative, you can register a custom delegate in DI to get the datetime. Sure. So you don't need to actually have an interface in a class. Yeah, a more functional approach. And then in your test, you could do the same thing if you're using DI in your tests, or if you just want to pass that func into the thing that needs it. All right, so here's some code that I hope would not pass your code review. And for a variety of reasons, right? It's not separating concerns. It's got whatever's happening when you check out your shopping cart, and it's doing this sending of an email. And it's not just sending an email; it's sending an email in a very specific manner that's actually using localhost SMTP to send the email. And so it's not abstract at all. If you wanted to test this code out on your local machine, and for whatever reason you have IIS with SMTP installed, you're actually going to be sending emails from your local machine, which is maybe not what you expected when you were testing this system. So there's various issues here, but one of them is that we're tightly coupled to the implementation details of sending email, and that makes it difficult for us to unit test the whole checkout method and all the other interesting things that it might be doing and business logic it might have. So if we want to address this by refactoring it, the first thing we can do is just kind of pull that logic out so it's not in checkout. And what that would look like is maybe using a facade layer or something like that as an interim. And probably that will still, I think I've got a slide for it, that will still be tightly coupled, but it'll be easier to follow and it'll make the single responsibility principle a little better. But here's the hidden dependencies bit that I mentioned, is that this method doesn't necessarily say, and its constructor certainly doesn't ask for like an ISMTP provider, or an iMail sender, or something like that. So it is not following the explicit dependencies principle. And if you do try and run it, and you don't have an SMTP server running on localhost, it's just going to blow up with a runtime exception saying I could not talk to port 25 on this server, which is not ideal for someone that's trying to test the checkout functionality. So this base improvement of facade that I mentioned would be just pull out a static method to send the mail, and then use that as this helper that you would do. And so you see this when you do like extension methods, sometimes to kind of clean up code. And I took the 6 lines of code that were there, and now it's 1 line of code or 2 lines of code, however you want to measure that. It's pretty easy to follow. Still the exact same logic happening, right? And if you look at the control flow when we run this code, it's still going to do the exact same statements. And so it's still just as tightly coupled. So that's an interim, minor step. But if you're following like the Boy Scout rule and you're saying, leave the code better than you found it, I would say this is better than it was. Right? Especially if I was sending email in a bunch of different places. Now I'm doing it all from one place. I've made a better abstraction for this, even though it's still tightly coupled. Right? It's better. Now, if you want to make it even better still, you can use the strategy pattern. Strategy pattern just says, I'm going to take that functionality I need, I'm going to extract out into an interface. In this case, that interface is going to be just one method, send mail. I'll call it something like iSendMail. And then I'll implement that code. So I'll take that exact same code and I'll throw it into a method and put it on some new class, and I'll come up with some name for that class. The name should be appropriate to the implementation details of what it's doing. So don't call the class send mail or mail sender, right? It should be specific to the way it's sending mail. It's a SendGrid mail sender. It's a local SMTP mail sender, or whatever you think makes sense. But it should be very clear when someone looks at that type name exactly what the infrastructure is that it's using, what the implementation details are that it's using to meet that interface. Now I can go up to my cart, my constructor, I can tell it, hey, I expect an iSendEmail provider with this second constructor right here. And that gives me dependency injection, right? If you're doing anything with dependency injection, you're probably familiar with that. Pretty easy stuff. Now, if you're working with a legacy system, it doesn't have dependency injection wired up. It doesn't have a DI container. How are we supposed to get those dependencies into it? Well, you can still just new up the default provider right here. And so now you'll get the exact same behavior that you always had before, and all your legacy code that was just newing up a cart and expecting it to do its thing still works just like it always did. But we've added an additional seam so that we can pass in other implementations. So in our test, for instance, we could pass in a fake version or a mock version or a test double that would let us do that. And so this is just a nice refactoring. Again, it doesn't clean it up entirely. This is still bad, in terms of technical debt, because it's still tightly coupled to that particular implementation, but it lets us check in some code and move on with our lives and leave the system in a working state. We make incremental improvement without having to refactor the entire universe and say, well, I can't do this without adding a dependency container and doing all these things and following all of solid. Like, you don't need to scope creep this thing into something that's untenable. You can just do little bits of refactoring that make things slightly better over time. Okay, so then anything else that now wants to call this is going to be a little easier to do. So your checkout method then just uses that local field. Either way, it's either the newly instantiated one that gets called with the default constructor, which is what all the existing system logic does, or it's your new one that passes it in that lets you do it a different way now and make it testable. Someone's mentioning, Richard says, mark the old constructor as deprecated. Yeah, if you want to put obsolete on here, that could be helpful, or at least a comment or a to-do that says, fix that up, because this is still technical debt. And if you miss it, it can cause problems. For instance, this works great for being able to inject this, but it only works if you're trying to test this code directly. If you're trying to test a service that uses this cart, you're still hosed, right? Because you still can't get to how this thing gets created if you're testing a service that news up a cart, right? You've moved the problem one step, but you haven't fully solved the problem yet. Unfortunately, if you do mark this as obsolete with the obsolete attribute, that's going to give you compiler warnings, which you should have set to break the build. All right, you should treat compiler warnings as errors pretty much on every project, so that you don't just ignore them and let them accrue. And so, I would probably add a to-do comment to this, not an actual obsolete keyword, just so I would not break all my builds, because I always have compiler warnings set to treat as errors. But whatever works for you, just so you eventually get to it and clean it up and identify that it's an issue. Alternatively, Steve says, can register a custom. Oh, I saw that already. I've used an iNotification service interface before and then had email, SMS, etc., and a check to see which one to use. Yeah, that's a good way to do it as well. Yeah, it doesn't have to be as specific as this. It doesn't have to be implementation specific with iSendEmail. It could certainly be a more generic notification. You do have to be careful with that. Like, it sounds great in the abstract to be able to send a notification in a totally abstract way and then let customers like opt in to how they want to be notified. But the details of what you need might be very different with an email versus with a text, right? You don't really need a subject and a message with a text. And you can deal with all that inside the individual providers, but it does mean that this method signature starts to get a little trickier to figure out. And it's not impossible, but it can add complexity to your system if you start doing that. Whereas sometimes it's easier if you just are specific about which type of notification you want. And that's why this is, somewhat art, not science, right? Use what works for you in your system. But these are just some heuristics and some patterns and some refactorings that you might use to try and, move toward a more quality solution that works for your specific requirements. A bunch of people like the idea of using warnings as errors. And yes, I agree. That's sometimes easier said than done. The other thing is, if you're shipping a NuGet package or a provider, and you want to notify the world that something is changing without immediately breaking them, then you can certainly use obsolete to mark things. And then folks will know that, they can, if they aren't using warnings as errors, they can upgrade and they'll see those warnings to let them know, okay, I'm on version 7 and in version 8 this thing's going away, so thanks for the heads up. Or if they are using warnings as errors, they maybe can't upgrade it, right? And they're like, okay, we're on 6, I see in 7 that this is obsolete, I'll have to wait until I can deal with that before I upgrade. And that works fine. All right, that's pretty much what I've got for this presentation for tonight. There's some other resources here, links to Pluralsight courses, devbetter.com, find me on all the things. Literally just a couple days ago, I set up gumroad.com, which is a place to share books and writing and materials. And I added some domain-driven design labs that I used in a workshop last week. The workshop was like $300 or something for each student. The labs are $19. So if you want to see those and give them a shot, feel free. They're less than a week old, so they're current, they work. And I'm just giving Gumroad a trial to see if it works for me. So far I've sold 2, so I'm getting rich. Yeah. That's all I've got for that. So open to questions here. Mike says he's not a big fan of Gumroad. All right, I've mostly only heard good things about him, but I'm interested in anyone's experience with Gumroad too.
Cool. Any questions, guys? Any questions? Any more questions, I should say.
Yeah, I appreciate all the questions as we went. That definitely was good to have that discussion. Regarding the infamous rectangle square, I always wondered why would someone create such a relationship in the first place? I feel like there might be an interesting discussion around that decision. I think it's because it's a naive approach to object-oriented programming, where most people learn inheritance as being an is-a relationship, and most people learn geometry and they learn that a rectangle is a quadrilateral and a square is a rectangle, which is a quadrilateral, and then they just connect the dots and say, okay, well, if that's how this works, then I should do that, right? Um, and that's because is-a is not sufficient, right? Is-a is that redundant there. The is-a relationship is a step toward what needs to happen for polymorphism. Is substitutable for is the actual relationship that should be used. So if you ever find yourself teaching object-oriented programming and polymorphism and inheritance, you should say this is substitutable for this other type, not this thing is something else. Magnifique. I don't think I've ever had my talk called Magnifique. That's awesome.